right, well, thank you very much for inviting me, Paul, yet again to speak to the Toronto Center. I think that almost all of you know me. Michael Watts, I'm a member of the board of directors of the Society. The Toronto Center member way back when, and I come generally about once a year to speak to the Toronto Center. I joined the Society 48 years ago in 1970, and I've been a member continuously since then. And some of you will know, those of you who follow any of my astrophotography on my Flickr page will know that that's one of my main interests now, as well as solar eclipses. So I first, I think it's fair to say that every observational astronomer who lives in the northern hemisphere wants to get into the southern hemisphere at some time in her or his life, and in my case, as many times as possible, because there's just so much great stuff down there. And for northern hemisphere astronomers, particularly observers who are interested in the Milky Way and the center of the Milky Way, it is just so tantalizingly low in the sky for all of us in the temperate latitudes here in the north. So I first got into the southern sky in 1983 when I went to see the great long 6.5-minute total solar eclipse in Indonesia. I went back in 84 and then went back to see Halley's Comet from the center of Australia in 86 and then 89. And then for 25 years didn't go back. And I think that has something to do with the fact that kids came along. And so for our 25th wedding anniversary back in 2014, Helen and I decided to go back down and remembered how much we loved it, went back in 2015. And then our daughter happens to have graduated last year, was in Australia, so we decided to go to Australia again in May of this year. Now, in the previous trips in 2014 and 2015, I had taken a small little Ioptron tracking mount. A Skywatcher, I've also got an Ioptron one, a tracking mount for camera lens astrophotography, and I was fairly pleased with the results. But this time I wanted to do something better. I wanted to take a small telescope, a Teleview 4-inch or 101 millimeter refractor, and so I needed a heavier mount. And I think those of you again who are on the RASC list will have seen some of my photos in the description of that. So we went in May. I bought a new mount, a small mount, back last fall, tested it out, tried it, and this is going to be the story of that trip. It was a 4-week trip through Australia. And it's going to be a little bit of a photographic tour. So you can turn the light off me and the camera off me, because the whole thing from now on is going to be photographs, a bunch of astrophotographs. But one of the things that, why do we do this, and what can we see from Canada from our latitude? Well, this is black and white, but this is the Milky Way, just apropos of what Chris was talking about, the summer triangle, which you can see here, Vega and Deneb and Altair, and the summer Milky Way from Cepheus on the left all the way down to Scutum, the great star clouds on the right. And, there's an awful lot of great stuff that you can see. But this is the northern Milky Way. This one photographed from Algonquin Park, and we can see also a couple of, we can see here a satellite and here a meteor. And so this is fine, and this is great, and this is what we are used to in the northern hemisphere. But taking May, for example, and I'm using Dave Lane's ECU Earth-Centered Universe program, this is what we will see at about 4 in the morning and in May, and this was the time that we went. And we have the horizon here, of course, and the teapot of Sagittarius and Scorpius. The tail of Scorpius is very, very low on the horizon. Back in May, Saturn and Mars. And here we have the plane of the galaxy. So this is the Milky Way running down. And this is what we can see here from our latitude with these familiar constellations that we have all grown up with. And there is the center of the galaxy again, fairly low on the horizon, the great bulge of the Milky Way, which we can see but not all that well. And everything down there we can't see. And of course, conversely, if you're down there, you can't see what's up here, but I think that they in the south probably have a better deal. And so what is missing that we can't see from this latitude? Well, some constellations we're not really all that familiar with. You'll see some photographs of these Ara, Norma, and Lupus. But more interestingly, and what I call the great three C's of Centaurus and Crux, the Southern Cross there, and Carina, which are, I think, my three favorite constellations in the south. We also have Triangulum Australis, Tucana, which has two actually really interesting objects, and then Octans, which performs sort of the same function or is in the same position in the south as Ursa Minor is in the north, because that's where the south celestial pole is located, although it's much more difficult to work with. And then we have the small and large Magellanic clouds, which are sort of detached parts of the Milky Way. They look like it, part of the local group in orbit around our Milky Way galaxy, and that you cannot see from our latitudes at all. And so if you want to see the Magellanic clouds, you have to go south, which is what we do. So this was this particular trip. This is a little shorter than our others. As you can see, it was 4 weeks, and this was our trip. It was 8,400 kilometers. Usually when we're in Australia, we do a circle trip, and so it ends up being either 11 or 13,000 kilometers. But this one we started in Melbourne. We flew there instead of Sydney, and then finished at Darwin, and then flew back, left the car there, rented a car here, left it, well, it was actually an SUV for the equipment we had. And these are the various places that we went. Now, when you're planning a trip like this, if you're an astronomer or an astrophotographer, you always need to plan around new moon. And so my wife Helen always asks me, okay, so we're going to Australia, when's new moon? And she knows that when it's new moon, I don't want to be down here, and I sure don't want to be in Sydney. So at new moon, this is where I'm going to be. And what that means is you work backwards from the time of new moon and figure out when you got to fly to Melbourne so that you can get up there, doing a lot of things along the way, and you're going to see some of that. And so that's how I go about planning these trips. It's all centered on new moon. All right? And so one of the things that's really important, bearing in mind, of course, that it's the opposite side of the seasons, is I prepared this. So this is for every day and where we were going to be every day during the whole trip, and then what the phase of the moon was, new moon here when we got to Alice Springs, and then the start and the end of the dark sky. And by start and end, what I mean is, bearing in mind moon, when the moon rises in the evening or sets, and when astronomical twilight either starts or ends. And so for the local time, which was Central Australian Standard Time, because they don't change to daylight at all, these were the times of the start of the dark period and the end of the dark period, and then the amount of time I had from the end to the beginning. So as you can see, after full moon and getting to our last quarter, you have only 1 or 2 hours of 3 and 4 and so on. But when you get in around new moon, I was getting 9 and 10 hours of darkness per night. And that's when I wanted to do my work. A lot of the time in here, we were visiting wineries instead, as you will see. So one of the things for if you're doing any kind of serious astrophotography, and I pretend to do serious astrophotography, is you have to align your mount with the pole. In the northern hemisphere, it's really easy because you've got Polaris, a second magnitude star that's about 52 arc minutes, or a little less than 2 moon diameters, maybe 1.5 moon diameters away from the actual pole, and it's quite easy to align your telescope on the pole. In the southern hemisphere, there is no bright or even moderately bright star actually anywhere close to the South Pole, and it therefore is really quite tricky because the closest star is Sigma Octantis, which is a very faint star. And so what I did is, and I do this regularly now, is I prepared finder charts, again using ECU, or Standard Universe, and starting off, as you can see down here in the lower right, a 40-degree field, because I wanted to find out and remind myself about where everything was and approximately where the South Pole was. And starting here using Alpha Centauri, which is Regal Centaurus now. The International Astronomical Union recently changed the official name. And then Triangulum Australis. These 3 stars I use at this time of year because they're really quite bright, it's really compact, and I can figure out exactly where I am. And from there I can star hop over. and then going in now to a 20-degree field. This is where the south celestial pole is. These are the 4 stars I use, and you see they're all 5th magnitude stars. These are faint stars, and so you have to use a finder scope. But if you can use these other stars, 3.8, 3.9, star hopping over from Triangulum Australis, you can get over here pretty easily, and then you will quite easily see, even before twilight is finished, these 5th magnitude stars coming out. This is a very familiar shape to me now. I know exactly where it is, and then you get really close and you can see some of these stars, and you can get a very good polar alignment. And so I think on the first night in this trip, it took me 12 minutes to get a polar alignment, and then from then on it took me about 5 minutes each time. When you get up to Kakadu National Park, where you're at about latitude minus 20, this part of the sky is really low on the horizon, though, and so it makes it much more difficult. So this is absolutely, in my view, vital preparation if you're going to do any kind of serious astrophotography and don't want to shoot yourself when you're down there because you can't get a polar alignment. One of the things I do as well, depending on the time of year I'm going down, is just to figure out at the end of twilight, where are the things that I'm going to be interested in. And so here for Coober Pedy, which is where I was going to start my work in the outback of Australia, this is on May 11th when we were going to arrive there. The end of twilight, where is stuff? And so we have the Large Magellanic Cloud here. We can see Crux, Alpha Beta Centauri, Crux, and Carina here, not yet. And this is due south, by the way, so not yet at the highest point. And what this told me is, first of all, the Small Magellanic Cloud at this time of year is impossible to photograph. It's just too low. Okay, fine, I got it a couple of years ago. But this time, the Large Magellanic Cloud here is going to go down into, remembering this is the southern hemisphere, so everything appears to be rotating the other way. It's going to be going down toward the horizon. And what that meant is, at the end of twilight, it was going to be 35 degrees up and getting lower. So it had to be one of my first targets that I was going to shoot this time. And well, we'll see in the photographs whether that worked or not. So this, and as you can see from all of these clusters and so on, this is the Milky Way. And at this time, at the end of twilight, the Scorpius and Sagittarius have not yet risen. And so that's going to be much later in the night, well, actually sort of early in the morning. And then in the morning, as astronomical twilight is starting, you see the Small Magellanic Cloud is a little bit, that's okay. If I wanted to, I could shoot that. And we have Scorpius Sagittarius here, and now Crux is descending down the sky. And so this gives me an idea of what is available to photograph during this period of time, and it is actually one of my favorite times. So, how many people have heard of this? How many people have one? All right. How many people like it? All right. I've got 6 copies of this. I have one at the office. I have one in the kitchen. I got one in my office upstairs. I keep 2 in the car, and then I have one packed to go to Australia. It is absolutely the most useful thing that I use. And the nice thing is that, it's really cheap, and you can get it from Sky Publishing, and so it really is really terrific, and it is fantastic to use at the telescope. I've been using it now for years, various incarnations of it. And one of the things I did is I photographed some of the charts, and then put it in Photoshop and put all of this stuff on. And then printed them into 8x11 glossies, put them in sleeves, and so I could take them right with the telescope there, 8.5x11 sheets, and I could see where everything was that I wanted to photograph. All of the Messier objects and so on. Obviously, this stuff is visible, although fairly low in the sky from here. And then going and then down into the tail of Scorpius, which is difficult to photograph here, and in the southern hemisphere, at about 3 in the morning, it was directly overhead. Which makes it just fantastic both to see and to photograph. And then we get into Alpha and Beta Centauri, Crux of Southern Cross. This is a really interesting hydrogen gas cloud here. And then moving over to the Eta Carina Nebula, which is one of my favorite objects in the entire sky. And so this is what I took with me, and it really made it easy. By now I know where all the objects are, But, first night out, I have to remind myself, oh yeah, that's there, and that's there, and that's there, and so on. And so this is really, really helpful. And if you're doing astrophotography, you don't have all that many nights, and you want to know where everything is and be able to turn to the stuff really, really fast. So here we are, arriving at Melbourne Airport, and yeah, that's all the stuff we had for a month. And there is the telescope. Well, actually, that's the telescope mount. The telescope itself is in my wife's suitcase. And what I tell her, well, what she tells me is, my clothes are really small and light, so why don't you put the telescope in my bag and everything else. This one here is actually, that carried the counterweights down, but most of it is empty, and that's because we used it to bring wine back. Which we do every time. Okay, so we start off in Melbourne. I'm just going to give you just a really, really quick little travelogue, because if you're an astronomer, you are curious. And if you're curious, you like traveling. And if you like traveling, you like spending time in really great and interesting places. And so we started in Melbourne, where our daughter was. She, by the way, she'd been there working for a better part of a year, and gladly hooked up with us for 2.5 weeks, because we were going to show her our Australia, and places that she would never necessarily get to. So the Yarra River, which goes up about 40 kilometers up to the Yarra Valley, where a great Australian Pinot Noir is grown, and it is just an absolutely beautiful city. And so we stayed there for a couple of days, and then headed off along the south coast of Australia, that some of you will be familiar with. How many people have been down there, the south coast, down to, okay, well, all right, a lot of people familiar with that then. The Great Ocean Road, the Port Campbell Coast, the 12 Apostles, well, there are actually only about 8 of them now because a bunch have collapsed, but that's okay. They don't want to get rid of the name. And what's really amazing when you get down there, and so, well, let's see. This really is one of our favorite beaches. And what's sobering is you look out across there and you realize the next land is Antarctica. So it's a pretty great drive. And so those of you who put your hands up will be very familiar with this view, I think. Early one morning we were actually leaving the Port Campbell coast. That is exactly what it looked like. And there are the remaining apostles. And so this is one of the things that we really like a lot. And you can actually, if you travel in the Outback particularly, you can see a lot of these in the wild. This one, not so much. So we have this little guy being carried around. And this really is a lot of fun. There's some absolutely fantastic game parks there. This one actually was in the wild. And this is shot from about, 50 meters distance with a very long telephoto lens. Beautiful parrots all through Australia. That's a galah. They pretend to be fierce. They look fierce, but they're not. They're just absolutely fantastic birds. The crimson rosella. This is down on the southern road. And they're really friendly and very curious. This actually quite amazed us when we first stopped there, I think 3 years ago. Anyway, they're looking for food and just sort of a nice conversation, and it's a lot of fun. This is a wild emu in the Outback, right along the Stewart Highway. It's really amazing. Every time we drive past this area. On the 800 kilometers from Kurupidi up to Uluru, within 10 kilometers, exactly the same stretch of road on the same side, this is where we see emus. This time, however, I spot a flock of 20 of them. And so I've got some other photographs that I haven't yet done. But this is one of the big ones. Again, photographed from as close as I could get before they started running away. Seals on Kangaroo Island down about 120 kilometers from Adelaide. One jumping out of the water. Luckily managed to be able to get that one. And then, now, this is really interesting. You could do, this is in the wild by the way, you could do, as astrophotographers do, about 55 stacked frames of a koala, and it would not have moved. You could walk all the way around it in 18,600 years, a precession cycle, and it would not have moved. They're fantastic, but you know, you can really take your time photographing this stuff. It ain't like a solar eclipse where you've got to be shooting. So that's one little guy that. Oh, he was at Kennett River, and I know where to look, and I managed to sort of spot him up in a little crook, and then showed a whole bunch of other people. And this is a wild dingo up in Kakadu National Park. This one actually is very scrawny. Most of them are really beautiful. They look like wolves, and but this one was kind of scrawny, and I think in a bad mood. And then again up in Kakadu in the very north end, Kakadu National Park is one of the great wonders and treasures of the world. Asian water buffalo were introduced back in the 1800s by the British, and then they kind of lost interest when they left, and so they've been rampaging through the wetlands. And this is one of these fellas, and it's a real problem there. They've been trying to get rid of all sorts of feral animals. Anyway, so this is the kind of thing that you can see when A, the sky's cloudy, or B, there's a moon in the sky. Oh yes, and of course the crocodile, one of the fiercest animals in the world. Yeah, so you don't want to get too close, for sure, or at least not look too yummy to them. And north of Kurupiti, heading up about several hundred kilometers south of the red center. This is really what it looks like. The color, these are the colors. And one of my first observing sites was about 100 kilometers south of here, just sort of off the road. And you get a pretty good horizon. And of course, everybody will be familiar with Uluru, originally, or well, the European name being Ayers Rock. In the center of Australia, one of the great icons of Australia. I first climbed it in 1983, and I think this year was the third time we climbed it. Next year, on October 28th, I think, October 28th, 2019, will be the last day for climbing, and it will be closed for climbing forever. One of the things that I did years ago, back in 1986 when I went down to see Halley's Comet, is something most Aussies have never even heard of. I swam on top of Ayers Rock because it was in after a spring of real torrential rains, and the rains had stopped about 2 weeks before I arrived, but there were pools and the fissures on the top, and you could just walk up and go all over wherever you wanted to. Just looked around, there's no one there, just stripped off and went in swimming. So I swam on top of Ayers Rock. Anyway, so, you know, why don't we, well, yeah, just I guess one last thing. So here we are in the Barossa Valley with Stephen Henschke, one of the most famous winemakers in the world. Tasty and his private cellar, we're sort of friends with them. And, you know, we spend a fair amount of time there, again, before the moon gets into the right phase. So, into the sky. And so, setting up. And this was actually done just outside Alice Springs. So this is the gear that I took. The equatorial mount that I bought. I think this one is something like $1,400. You know, not super expensive, but a nice little mount, and I was fairly happy with it. This was a Teleview apochromatic refractor, which is a really nice photographic scope. I actually had to buy a power tank battery down there because I was thinking about taking one down and shipping it, and it would have cost $400 to ship it. So I just bought one down there for $300, but I couldn't get it back, so I had to leave it. This is so I decided for this one not to use a smartphone, Dennis, and I think that not that the results would have been not as good. However, there we go. A Telrad finder doesn't have a regular finder scope because the focal length is fairly short. But it's a really nice photographic scope and a really good ball head for putting the camera on with camera lenses. And then you've got the astrophotographer. And so this is the setup that I used. And you can see here, I think, the elevation above the horizon from Alice Springs of where the South Pole is. It's not actually all that high, which makes it a little bit of a challenge. But that's okay. And of course, when you're out, you hear all sorts of rustling and everything, and you just know there are animals all around you. But all you do is you hear them. and you just can't see them all. So we're going to start with the southern Milky Way, and I had certain things that I really wanted to photograph this time, and I did a lot of. Any of you who follow my work know that I really like wide-angle work, and so we're going to start here with, as we can see, Southern Cross, the False Cross. Now, everybody's heard of the Southern Cross. The False Cross is located to the west of the Southern Cross, and it rises therefore earlier. In the southeast, it rises earlier. And bear in mind, of course, we are used to, in the northern hemisphere, if that's the south, we're used to the sky rotating this way, well, because of the direction we're looking in. But in the south, when you're looking toward the South Pole with all of this stuff, the sky is rotating in the other direction. And so everything is rising in the southeast and moving across. And so what you see first, and a lot of people think is the Southern Cross, is in fact the False Cross. You probably can't pick it out there, but I'm going to show you in the next one. And so what we have, okay, there we have the False Cross, which is larger than the Southern Cross, same general shape and kind of orientation, and you can see how it fools people. And I remember it fooled me first time decades ago, actually. And so this is just one of the great areas of the sky. And you can see that there is an awful lot of stuff here. The Southern Cross, very bright stars, except Delta Crucis, which is only 2.7. But these are all first magnitude stars. And so it's very, very prominent. It's a tiny little constellation here. It doesn't have to be bigger. It's got a lot of stuff here. And then we have, obviously, the great Eta Carina Nebula, which I'll talk about later. And here we have the galactic equator. So you can see that the plane of the Milky Way goes right through this area, which is why you have these great star clouds. And they're just really beautiful. And obviously, when you get away from that, you have a fair number of stars down here, but not nearly as rich as in the Milky Way. And here, and this is very prominent, we have a great big foreground dark gas cloud, very large in size, which is called, not surprisingly, the coal sack. And it really looks like a big hole in the sky. And so you got the Southern Cross, crux, and then the coal sack side by side. And you can see these objects naked eye, although obviously you can't see the colors because of our eyes and the way they work. And then a very large open cluster, the southern Pleiades. You'll see some close-ups of those. So this is an area of the sky that we never see from here and really is just absolutely gorgeous. And so moving over just a little bit now, what we have here again is the Southern Cross, and then Alpha and Beta Centauri, Hadar and Centaurus. And real Centaurus is magnitude 0.0. So it's a very, very bright star, one of the brightest in the sky. And a huge star cloud here, which is very similar to M24, the great star cloud in the Scutum area. And then here are the southern Pleiades. And then this little thing. It goes by the old ancient Greek moniker, the dark doodad. And this was first kind of noticed and described by Dennis DeCicco of Sky and Telescope when he did a photograph outside Alice Springs in 1986. He was there to see Halley's Comet, as I was. And he photographed this and noticed this sort of sinewy, dark cloud, and he just called it the dark doodad. Well, it's as good a name as any. And so you can see here, this is just really a terrific area of the sky from Centaurus here to Crux and Carina, one of my favorites. It's just so gorgeous. You spent a lot of time here. So now we have a close-up using a 200mm lens of Crux here, the four stars. You can see that Delta Crucis is a lot fainter, but these three are very obvious. And then the coal sack. There are obviously stars there, and foreground stars, but a lot of the background stars are completely hidden. And right in here, near Mimosa, this star is a really tight little open cluster called, not surprisingly, when you look at it through the telescope, the jewel box. It is just so gorgeous. And one of the things you can see as well here, very prominently here, are the different colors of the stars. They are very obvious in this view. Okay, and again, the galactic equator going all the way straight through here. Okay, so That is Crux. And here we go. This is taken through the telescope. That was a 200 millimeter lens. This is taken through the telescope. And we have Mimosa here. And then the jewel box only about 1.5 degrees away or so, with a bunch of other objects, little open clusters as well. TR for Trumpler, who discovered or described that open cluster. All right, and then I point out the southern Pleiades. This is actually really interesting. The southern Pleiades have some bright stars as well, as you can see, and around the same size as the northern Pleiades, not quite as bright, and without the blue reflection nebulosity that we have around M45, the northern Pleiades in Taurus. And what's sometimes kind of overlooked because of the brightness of this is this really nice little rich cluster here. It's not as bright, but it's a really pretty cluster to see through the telescope. So I will do a photograph and then take it off and camera off and put the eyepiece in and take a look at these objects after I've photographed them. And then Regal Centaurus, again, one of the very brightest stars. This is a tricky photograph to make because the star is so bright, and and how do I photograph it without having it overwhelm the entire frame? But there are all sorts of little large and small open clusters here. This one is really interesting, Pismus 19. You can see that there's a little bit of color there. This is a very distant open cluster, and as a result, it has to pass through a lot of gas, and the gas reddens the light, and that produces that orangey color. And so that is one of the keys, that this is a very distant open cluster, which is a very interesting thing to see. Of course, you can't see it with your eye because your eye can't see those colors, but the long exposure photographs show this up really well. Now, there's an astronomer by the name of Gum in the southern hemisphere some decades ago who did a survey of gas clouds in the southern sky. And these, most of you will know this, but some of you may not necessarily. These are actually true colors. We can't see them with our eye, but these are glowing clouds of ionized hydrogen gas, H2 regions. And they are ionized and caused to glow by hot young stars that are very close by or actually embedded in them. And you can see this throughout the entire area. There's an enormous Gum Nebula, an enormous one. You can sort of see. Oh, sorry, got to go back. Yeah, okay. You can see all of this. There's sort of faint red nebulosity all around, and then big knots of larger discrete nebulosity there, and this is throughout the entire area of the southern sky. And again, my Star Atlas showed that there were these things, and I was hoping I'd be able to get something with these Gum objects, and I was, and so I was fairly pleased with that. I'm not going to pretend that these are the world's best astrophotos. They're not, but with a little amount and the time I had, this is what I was able to get. This is a much larger one. I should point out the constellation Vela, the old Latin pronunciation would be Vela. These are really interesting constellations. You have Carina and Puppis and Vela or Vela. These constellations all used to be one huge, large one in Greek mythology, Argonauts. That is the ship of the Argonauts. It was a huge constellation and kind of unwieldy. And so in modern times, it has been broken up into 3 separate constellations: Puppis, the stern or poop deck; Carina, the keel; and Vela or Vela or Vela, the sail, all parts of the ship. And so you can sort of bear in mind the Greek mythology as you're looking at these constellations. Okay, and again, the galactic equator, we get a lot of this stuff right through the plane of the Milky Way. This is one of my favorite ones in Centaurus. It has, it reminds me a lot of you will have seen photographs of the red nebulosity around the central star, Gamma Cygni, in the Northern Cross. And this reminds me an awful lot of that, both in color, extent, size, and so on. And this is one of the objects that I really wanted to try to be able to photograph this time around. And all of these now are higher magnification through the telescope. Generally about a dozen identical stacked images. And I just decided to throw an extra camera on a tripod while I was doing some other stuff and see the Milky Way then setting in the west with the large Magellanic cloud. This would be about 11 o'clock. And so Crux and Centaurus are sort of off the screen to the top, and you can see the Milky Way then setting in the southwest. It's quite a pretty view. This is one of the objects that I really wanted to get. I had three main targets, and this one, Omega Centauri. Now, what kind of object is this? Sorry? Okay. So, until, I don't know, 20 years ago or so, it was considered to be a globular cluster, globular star cluster, and by far the brightest of all of them in the sky. The two brightest of these objects are invisible from our latitudes, and they are Omega Centauri and 47 Tucanae. They're in the far southern sky. And then we have, obviously, some bright ones in the north, M22 in Sagittarius that a lot of people are familiar with. I photographed it recently up in Algonquin Park. Is another very bright one, but these two, 47 Tuc and Omega Centauri, take the cake. However, it now really is generally considered that Omega Centauri is a small dwarf galaxy, the remnants of a dwarf galaxy that has had its outer stars stripped away by interaction with the Milky Way. And so we don't call it a globular cluster anymore, although if you go to Wikipedia and many other sources, for example, the Trump White House, you will get the false news, the fake news that it is, in fact, a globular cluster. Well, it's not. It is, so that's what it's considered. And I got to tell you, I did not know that until recently. Peter Jedicke of the London Center, a longtime member, as long as I've been a member, told me about that, and so I did some investigating and reading and found that out. Anyway, this is a tricky object to photograph and to get all of the outer extent while still showing resolution in the middle. And so this took a lot of work to get this. But I'm actually fairly pleased with the resolution, and it's huge. It's about the size of the full moon in the sky. And I really like that object. So if I come back with only one astrophoto, I would have considered it a success. And this is the one that I really wanted to get. Now, the other one that I wanted to get, and I'd photographed it before, is the great Eta Carinae Nebula. This is a very, very interesting object, and at its very center is the star Eta Carinae. This is a fantastically interesting star because it's kind of a cataclysmic variable star. It undergoes periodically bursts that are unpredictable. It is not an eclipsing binary. It is not a Cepheid variable with a distinct period. And no one knows exactly what causes this, but in the 1800s and 1860s, it underwent an enormous explosion in brightness and became the second brightest star in the entire sky after Sirius, and even brighter than Canopus, for a short period of time, and then sort of went up and down over the ensuing decades, faded below naked eye visibility, and has now come back in recent decades to around fifth magnitude. And so it's just a really fascinating star, and also is the engine that ionizes the hydrogen gas, and has produced this incredibly detailed, highly structured nebula, and all of this stuff. And it's important to realize that these dark lanes are not holes in the nebula. They're foreground dark gas clouds that hide the nebulosity behind, in exactly the same way as the Horsehead Nebula is a foreground dark cloud of gas that is silhouetted against the Zeta Orionis nebulosity behind it. And so it's kind of hard to visualize that and to think about that, because it just looks as though it's a hole in the nebula. Well, it's not. But this is really one of the great showpieces of the southern sky. And again, this is the color that the camera picks up. To put it another way, it is true color. And I'm going to, I've said this before, I think, at presentations that I've done here, and at the General Assembly in Calgary, I made this point again. And it's a point about photography, but it's a point about astrophotography. In general photography, what most decent general photographers want to do is to depict what they actually see with their eyes, what we consider to be reality, and to reproduce that for memory and all of that. In astrophotography, we have to appreciate that the human eye is a very bad detector of dim objects. And I'm not going to go into all the physiology of that, but it's fairly well known, and you can read up about that. And in particular, the human eye cannot see color at low light levels, and that is why, as twilight comes and so on, all the colorful objects seem simply to disappear. You can see the objects, but they just become gray tone, because the cones in our eyes are very light insensitive. They see color, but they're light insensitive, and they just shut down. So we can't actually see the colors. And so in most astronomical objects, we cannot see the colors with our eyes. Some of them we can. Bright stars are bright enough to trigger the cones, and so we can see the blue and the orange gold, for example, in the double star Albireo in Cygnus. We can see the shocking pink prominences on the edge of the sun during a total eclipse of the sun. We can see that because they're bright enough. We can see a little bit of the color in the moon, some of the blue and so on, but the moon is actually one of the darkest objects in the sky. It reflects only 18% of light that falls on it. It's very, very dark. And this is one area in which, however, the photographic film in the old days and the digital sensor now actually captures what is there and that our eyes can't see. And in a way, therefore, in astrophotography, it is an example of where the camera shows reality way better than the human eye can detect it. And so, people say, well, geez, these pictures are also colorful. That's not what we can see. That is true. And I acknowledge that. But that's what's actually there. And that is one of what I consider to be the advantages of astrophotography. You can see what is there. You can see it with your eye. If you want to appreciate what is actually there, if that's what you want to get from the sky, that's why we all do astrophotography, in my view. At the beginning of the show, I showed you the Milky Way in gray tone. Well, that's more what you see. And then I brought up the color, which is what the camera detects that the eye can't see. Anyway, so this is one of the great objects that I just adore. And we actually went in May, partly because I knew that this would be perfectly placed in the sky. You get down to November, when we were there in 2014, and it's too low, and we just can't see it at all. So to wrap up fairly quickly, we talked about this earlier, the Magellanic clouds, which we can't see from the northern hemisphere. And here, and this actually was done in November 2014. Here, just to give you an idea, because this kind of won't be familiar to you, here we have Orion. And we have, so Orion is here. We have the three belt stars and the Great Orion Nebula. And so off the screen directly to the right is due north, and this is due south, okay? So it's sort of tilted. And here we see the Rosette Nebula, and here we have Sirius. And so the line, the horizon line, what we can see from the northern hemisphere, kind of runs like this, and we can't see anything below it. And here we have, of course, the large Magellanic Cloud and the small Magellanic Cloud. And very close by, that's 47 Tucanae, which is a globular cluster. And now I would say is the brightest globular cluster in the sky. And so these objects are fairly close to each other. They are not in the plane of the Milky Way. They look like they're detached segments of the Milky Way. The large Magellanic Cloud is at about 160,000 light years away, and the small Magellanic Cloud about 200,000 light years away. So they're really close, bearing in mind that the Milky Way has a diameter of about 100,000 light years. So they're really quite close, and no wonder they have been tidally distorted, and they are in orbit around the Milky Way because of the immense gravitational pull. And so here is a 200 millimeter lens photograph of those, again, from a couple of years ago. And the small Magellanic Cloud here, and we can see 47 Tucanae, and as you can see, it's so bright in the center that it just gets burned in with any kind of exposure, and it's hard to get both the outer stars and any detail in the inner part. But that's a small cloud. And then, that was a couple of years ago, and then this one is what I really wanted to get this time, and it's the large cloud. And what we have here is the great Tarantula Nebula. And this is one photograph that I really want to get as well. And I was actually very pleased that I was able to get the detail in the Tarantula Nebula and also get, a lot of the bright features of the Large Magellanic Cloud. And so a lot of these in the Large Magellanic Cloud actually have their own NGC designations. So these, again, are clouds of glowing hydrogen gas, not in our galaxy,
but in this very bright member of the local group of galaxies that contains about 20 galaxies very close around. The Andromeda Galaxy, M33, which are the two brightest and largest ones, and then these two other much closer members with a lot of open clusters, which are foreground objects, obviously very close to us. And so you get an awful lot of these. And I got to say, I was really quite astonished when I saw the frames when I got back to Toronto and started processing these and saw, wow, there is an awful lot of hydrogen alpha in this area. So that is the Large Magellanic Cloud, and I was kind of happy to get that. And then you wait for the Milky Way. The center of the big bulge should be straight overhead, and that's when you photograph it. And so this is the center of the Milky Way right overhead at 3 in the morning from Coober Pedy, South Australia. And we have here Antares. The horizon line from Canada would go approximately here, so we don't see any of this. And we have, of course, here the Lagoon Nebula M8, the Trifid M20, the Omega and Swan Nebulae there, various objects that we're all familiar with. The Dark Pipe Nebula, which is difficult to photograph well here, again, because it's so low, but it's very prominent when you see it from the south. And so this is the center of the galaxy right there, and of course the familiar star patterns, and we are familiar with those. And there's an awful lot of stuff here. We have the Eagle and Omega and Trifid and Lagoon, M28 and M22, the great bright globular cluster here. And then a whole bunch of these dark clouds. B is for Barnard, who investigated dark clouds. And so when you see the B, it is the great American astronomer Barnard. Colander is the CR, and so we have some of these as well. NGC for the New General Catalog, and IC, the Index Catalog, which is sort of the supplement. And then this great star cloud here, which is quite similar to the star cloud that you get in Scutum as well that we can see. So that is the center of the galaxy taken with a wide angle lens. Then zooming in just a little bit more, we can see now the tail of Scorpius, and we can see some of these objects as well. And we can see that these objects are in Sagittarius. Then just across into Serpens Cauda, we have the Eagle and M22 as well. So again, a little bit zoomed in. This is one with a 200 millimeter lens, you can get all 4 of these objects in, and they're really pretty. And they're great for star hopping too, bearing in mind that you just can't see the colors. And I like this one. So we have, obviously, the Lagoon Nebula, a great nebula with a fair amount of detail, and the Trifid that has 2 aspects to it. We have glowing hydrogen gas, which is the red emission nebula, and then the blue reflection nebula, light reflected off the nebula rather than gas that has been ionized and glows by itself. And it's one of the few objects in the sky that displays that, but the blue is a lot fainter than the red. So I was fairly happy to get this. And one of the things that we don't see all that often is that with the lagoon, there's a lot of nebulosity all around here. It's not just sort of this central area. And this is really interesting as well, kind of a serpentine dark cloud of gas that surrounds it. And then the tail of Scorpius. This is about as low as we can get. The horizon's right down here, and it's really hard to see well. But when it's overhead, it's a lot easier to photograph. And one of our favorite objects, I think people have seen this, is M7. It's a very bright open star cluster, and here it is. But what we don't see when it's low is how dense the star cloud is all around this, because it's right in the center, in the plane of the Milky Way. And when you're in the southern hemisphere, you can really see that really well. And then finally, we have Antares and the Rho Ophiuchi field, and you get an awful lot of interesting stuff there. Again, this is not the world's best photograph of this, but it's something that I wanted to try, and I think it's fairly pretty. And then a super wide-angle view to finish up here, the center of the Milky Way. And here we have Alpha and Beta Centauri and the big bulge of the Milky Way. I think I may have said this before, and maybe it's the last comment that I'll make, and it's this. students of the history of astronomy will be aware of the fact that when galaxies were observed with telescopes, starting in the 1700s and 1800s, there was a huge debate as to what exactly they were, how far away they were, and whether they were actually part of our Milky Way galaxy or far distant. A very great debate. And of course, they weren't called galaxies at all then. They were called nebulae. Nebulae, from the Latin, meaning cloud. So they looked like little bright clouds. Well, what exactly were they? And somebody will correct me. I'm sure I won't have the details right, but this led to the great great debate in 1920 between Curtis and Harold Shapley as to, which was held, I believe it was in Washington, D.C., as to the nature of these things. One of them taking one side, part of the Milky Way, one taking the other side. No, they're really kind of replicas of our Milky Way galaxy, and they're very, very far away. Well, ultimately, it was obviously determined, but only when Cepheid variables were discovered as the sort of distance marking stick that they were, in fact, external galaxies. And I read a long time ago, and this just makes a lot of sense to me. When you look at galaxies external galaxies through a telescope, M31, for example, probably the best example of that. You see it's tilted about 22 degrees to our line of sight, but it's got a great big central ball. And the argument that was made is, all of the astronomers were Northern Hemisphere astronomers back then. And so they were doing all of this figuring out and all of that. And they couldn't see our Milky Way actually all that well from the north, because the center of it, is really, really, really far south. Whereas when you are in the southern hemisphere and it's straight overhead, as I was in May, you can see the thinness of the Milky Way in the east expanding into this huge globular sort of ball and then thinning down as well. You look at it, say, my God, that's exactly what I see when I look at M31. And if the Milky Way had been visible in that way to Northern Hemisphere astronomers when this debate was going on, they would have seen that we are in the middle of what they're looking at when they were looking at all these other galaxies. And it would have been realized probably a lot earlier, maybe a century earlier, that in fact the galaxies are external and not part of our Milky Way. And so that's one of the things I think about when I'm down there, and I think about the history of this great debate and how Northern Hemisphere centric we are. And so it's an interesting thing to ponder while you're waiting for everything to get high enough to photograph. So there we have the Galactic Center again and our familiar star patterns. This is the horizon from our latitude. And so I will finish this way. Paul, I think I've probably taken more than my allotted time, and I don't know whether there are any time for questions, maybe not, but we'll leave it there.
Let's take a couple of questions.
If there are any.
I'm sure there will be some questions. Yes.
How long are your exposures?
That's a very good question. How long do you think they are? Every one of those photographs, every one of them was made, and they're all stacked, but every one was made with a 1 minute exposure. Every single one. Now, the Nikon D810A is a very good camera. It's a dedicated astro camera, as I'm sure you know. And I'm pretty careful with what with how I shoot them. But that's what they are. All of them. And so that's why I'm able to get what I get and as much as I'm able to get. And again, I do not pretend that these are the greatest astrophotos. There are a lot of RASC astrophotographers, Alan Dyer and Lynn Hilborn and so on, who produce, Lynn's got a permanent observatory. I got to lug my stuff up to Algonquin Park all the time. But it does show what you can do if you make the effort. And I appreciate that the equipment is expensive, but it shows what you can do with that kind of short exposure stuff. How many stacked frames? It depends on the object. For open star clusters where there's not an awful lot of detail as the stars, I will generally do 5 or 6. For detail, such as in M8, for example, I will always do at least 12 and sometimes maybe 16. Beyond that, the gain that you get is just not worth the effort. You just don't get any gain. And so that is the number that I will generally do. And using dark frames and so on, if I'm doing a stack of 12 on one object, got to multiply it by 2. So 12 objects, 1 minute each, 12 minutes times 224. So half an hour, in total of about half an hour's work, I can get all the subframes I need to put together an image such as the one you saw for the Trifid and the Lagoon. Half an hour for one image.
How far away were you actually from the dingo and the alligator?
Ah,
Or the crocodile. Just curious. They're great shots.
I'm going to say about 15 meters for the crocodile. They're crocodiles. 15 meters. We're on a boat, and I made sure it had a bloody fast motor. Well, no. You couldn't. But I use a 400 millimeter lens for all of that photography. Yeah. So 20 meters. It was on a boat because it was in Kakadu Park. Yeah. Okay, we done? Oh. Sorry? Not for the dingo. Yeah. No, I don't use filters ever. No. One more?
Great, Michael. What focal length lens do you use for an extreme?
Well, I actually didn't take my 15 millimeter ultra wide one this time. The widest I used was 24 millimeters, which is really nice, or 35, but 24 gives you really nice view. And I also use, for those of you who follow me, I use the Sigma Art lenses, and the Sigma lenses, they're fixed focal lengths. One is a 15, one's a 24, and they are incredibly sharp. But the important thing is, and I'll finish with this comment, and I've said this many times before, these lenses are f1.4 or f2 lenses. You never, ever shoot with them wide open. So the Sigma lens, which is a superb lens, Terry Dickinson recommended it to me years ago, just when it came out, and I got one. It's an f1.4 lens. I always stop it down to f4. Well, that quadruples or quintuples the time I need to get the photograph. But what does it mean? The stars are pinpoints all the way to the edge, and there's no vignetting. And most people ask me, how the hell do you get stars that way? That's what I do. And because the CMOS chips now are so good, I'll boost the speed up to ISO 3200, even 4000. And you still get really good quality in wide-angle photos. Okay, that's it. Okay, so thank you again for having me.